बच्चों इस एपीसोड विच तुसी सीखोगे मैट्रिसेस एडिशन यानी मैट्रिसेस दा जोड़, प्रॉपर्टीज ऑफ मैट्रिसेस एडिशन अते एप्लीकेशन ऑफ मैट्रिसेस एडिशन। तुसी पहला ही मैट्रिक्स अते इन्हां दियां विभिन्न टाइप्स बारे जानते हो। आओ हुण शुरू करिए। Addition of matrices. Let A, B be two matrices, each of order n by n. Then their sum A plus B is a matrix of order m by n and is obtained by adding the corresponding elements of A and B. Moreover, the sum of two matrices is defined only when they are of the same order. For example, matrix A, which is a square matrix of order 2 having first two elements as A, B, second two elements as C and D. Matrix B is also a square matrix of order 2 having first two elements as E and G, second two elements as F and H. Then matrix C, which is the sum of matrix A and B, will be equal to A plus B, that will be equal to square matrix of same order 2 having first two elements as A plus E and B plus G, second two elements as C plus F and D plus H. Scalar multiplication of matrix. Let A is equal to matrix having journal element as Aij, B and m by n matrix and k be any number called a scalar. Then the matrix obtained by multiplying every element of matrix A by k is called the scalar multiple of A by k and is denoted by k into A. For example, matrix A is m by n order matrix having first two elements as A11, A12 up to A1n, second two elements as A21, A22 up to A2n and so on. Elements of its mth row are AM1, AM2 up to AMn. Then when it is multiplied by a scalar k, it becomes matrix k into A, which is of the same order matrix, that is of m by n order matrix with first two elements as k into A11, k into A12 up to k into A1n, second two elements as k into A21, k into A22 up to k into A2n and so on. Elements of its mth row are k into am1, k into am2 up to k into amn. Consider multiplication of matrix A by scalar -1. Now observe that the elements of the new matrix so obtained have opposite sign to the corresponding elements of matrix A. This new matrix is negative of matrix A and is denoted by -A. Subtraction of two matrices. Let A, B be two matrices of order m by n. Then their difference A minus B is a matrix of order m by n and is obtained by subtracting the elements of matrix B from the corresponding element of matrix A and is defined as A minus B, that can be written as it is equal to A plus of minus B. Also, difference of two matrices is defined only when they are of the same order. For example, let matrix A be a square matrix of order 2 having first two elements as A, B, second two elements as C D, and matrix B, which is also a square matrix of order 2, having first two elements as E and G, second two elements as F and H. So therefore A minus B is equal to matrix A plus negative of matrix B, that is, it is equal to a square matrix of order 2 having first two elements as A minus E and B minus G, second two elements as C minus F and D minus H. Comparable matrix: two or more matrices are comparable if their order are same. For example, matrix A, which is a square matrix of order 2 having first two elements as 1 and 2, second two elements as 3 and 4, and matrix B, which is also a square matrix of order 2 having first two elements as 0 and 1, second two elements as 7 and 8, are two comparable matrices. Now, laws of addition on matrices. Commutative law of addition. Matrix addition is commutative, that is, A plus B is equal to B plus A for all comparable matrices A and B. For example, let A be a square matrix of order 2 having first two elements as 2 and 3 and second two elements as -1 and 0, and matrix B is also a square matrix of order 2 having first two elements as 4 and -2 and second two elements as 2 and 6. Then verify that A plus B is equal to B plus A. Now its solution. Here A is a 2 by 2 order matrix and B is also a 2 by 2 order matrix. So A and B are comparable because order of matrix A and matrix B is same. Now A plus B is equal to matrix A plus matrix B, and that will be equal to square matrix of order 2 having first two elements as 2 plus 4 and 3 plus -2, second two elements as -1 plus 2 and 0 plus 6. That will be equal to square matrix of order 2 having first two elements as 6 and 1, second two elements as 1 and 6. Therefore, A plus B is a square matrix of order 2 having first two elements as 6 and 1 and second two elements as 1 and 6. And B plus A is equal to matrix B plus matrix A because matrix B is equal to square matrix of order 2 having first two elements as 4 and -2 and second two elements as 2 and 6, and matrix A, which is also a square matrix of order 2 having first two elements as 2 and 3 and second two elements as -1 and 0. So it is equal to square matrix of order 2 having first two elements as 4 plus 2 and -2 plus 3 and second two elements as 2 plus -1 and 6 plus 0. That will be equal to square matrix of order 2 with first two elements as 6 and 1 and second two elements as 1 and 6. Hence, we can say that A plus B is equal to B plus A. Matrix addition is associative, that is, A plus B plus C is equal to A plus B plus C for all comparable matrices A, B and C. Now let's see an example to verify associativity of addition of matrices. Let A is a square matrix of order 2 having first two elements as 1 and 2, second two elements as 3 and 0, and B is again a square matrix of order 2 having first two elements as 2 and 0, second two elements as 4 and 1, and matrix C, which is a square matrix of order 2 having first two elements as 0 and 1, second two elements as 2 and 0. Then verify that A plus B plus C is equal to A plus B plus C. Now its solution. Clearly, each one of the matrices A, B and C is the square matrix of order 2, that is, 2 by 2 matrix. So A plus B plus C and A plus B plus C both exist, and each one is of 2 by 2 order matrix. Now first, A plus B will be equal to matrix A plus matrix B. Further, equal to square matrix of order 2 having first row elements as 1 plus 2 and 2 plus 0, second row elements as 3 plus 4 and 0 plus 1. That will be further equal to square matrix of order 2 having first row elements as 3 and 2, second row elements as 7 and 1. Now A plus B plus C will be equal to matrix A plus B plus matrix C, further equal to square matrix of order 2 having first row elements as 3 plus 0 and 2 plus 1, second row elements as 7 plus 2 and 1 plus 0 is equal to square matrix of order 2 having first row elements as 3 and 3, second row elements as 9 and 1. So here A plus B plus C will be equal to matrix having first row elements 3 and 3, second row elements 9 and 1, which is a 2 by 2 order matrix. Let it be question number 1. Also, B plus C is equal to matrix B plus matrix C is equal to square matrix of order 2 having first row elements as 2 plus 0 and 0 plus 1, second row elements as 4 plus 2 and 1 plus 0 is equal to square matrix of order 2 having first row elements as 2 and 1, second row elements as 6 and 1. So further, A plus B plus C will be equal to matrix A plus matrix B plus C. That will be equal to square matrix of order 2 having first row element as 1 plus 2 and 2 plus 1, second row elements as 3 plus 6 and 0 plus 1, that is equal to square matrix of order 2 having first row elements as 3 and 3, second row elements as 9 and 1. Therefore, A plus B plus C will be equal to matrix having first row elements as 3 and 3, second row elements as 9 and 1, which is a 2 by 2 order matrix. Let it be equation number 2. From equation number 1 and equation number 2, we get A plus B plus C is equal to A plus B plus C. Therefore, matrix addition is associative. Existence of additive identity. For a matrix A plus 0 is equal to 0 plus A, which is equal to matrix A, where 0 is the 0 matrix of the same order as the matrix A. Now, let's see an example. Let matrix A is a square matrix of order 2 having first row elements as 3 and 5 and second row elements as 1 and 2, and O be the 0 matrix of same order 2 by 2 having first row elements as 0 0 and second row elements as 0 0. Then verify that A plus O is equal to O plus A, which is equal to A. Now its solution. Now matrix A plus 0 matrix of same order matrix O is equal to matrix A having first row elements as 3 and 5, second row elements as 1 and 2, which is a square matrix of order 2, plus 0 matrix of the same order 2 by 2, that is equal to matrix with the first row elements as 3 plus 0, 5 plus 0, second row elements as 1 plus 0 and 2 plus 0, which is equal to matrix having first row elements as 3 and 5 and second row elements as 1 and 2 will be equal to matrix A itself, and O plus A is equal to 0 matrix of order 2 by 2 plus given matrix A, which is a square matrix of order 2, so it will be equal to square matrix of order 2 having first row elements as 0 plus 3, 0 plus 5, second row elements as 0 plus 1 and 0 plus 2. That will be equal to square matrix of order 2 with first row elements as 3 and 5, second row elements as 1 and 2, which is matrix A itself. So hence we can say that A plus O is equal to O plus A is equal to matrix A. So here O, which is a zero matrix of same order as of matrix A, is the additive identity. Existence of additive inverse for a matrix A plus negative of matrix A, that is A plus minus A is equal to minus A plus A is equal to 0, which is a zero matrix of the same order as of matrix A. Now let's see an example. Find the additive inverse of matrix A, which is a 2 by 3 order matrix having first row elements as 2, minus 5 and 0, second row elements as 4, 3 and minus 1. Now its solution. Clearly, the additive inverse of the given matrix A is the matrix minus A given by minus A, that is equal to matrix having first row elements as minus 2, minus of minus 5 and 0, second row elements as minus 4, minus 3 and minus of minus 1, that is equal to matrix having first row elements as minus 2, 5 and 0 and second row elements as minus 4, minus 3 and 1. Properties of scalar multiplication of a matrix. If A is a matrix having journal element Aij and B is a matrix with journal element Bij, are two matrices of the same order m by n, and K and L are scalars, then K into A plus B is equal to K into A plus K into B. Second, K plus L into A is equal to K into A plus L into A. Third, K into L into A is equal to K into L into A. That can be further written as it is equal to L into K into A. Fourth, minus K into A is equal to minus of K into A, which can be further written as it is equal to K into minus A.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਮੈਟ੍ਰਿਸਿਸ ਐਡੀਸ਼ਨ, ਪ੍ਰੋਪਰਟੀਜ਼ ਆਫ ਮੈਟ੍ਰਿਸਿਸ ਐਡੀਸ਼ਨ ਅਤੇ ਐਪਲੀਕੇਸ਼ਨ ਆਫ ਮੈਟ੍ਰਿਸਿਸ ਐਡੀਸ਼ਨ ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਨਾਲ ਰਿਲੇਟਡ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example given matrix A whose first row elements are 2, 3, second row elements are 1, 5, which is a scalar matrix of order 2, and matrix B with first row elements as 1, 3, second row elements as 4 and 2, which is a square matrix of order 2. Then find A plus B. Now its solution. Here, given matrix A with first row elements as 2, 3, second row elements as 1, 5, and matrix B with first row elements as 1, 3, second row elements as 4, 2, therefore A plus B is equal to given matrix A plus given matrix B so we obtain a matrix with its elements as the sum of corresponding elements of matrix A and matrix B respectively. That is, it is equal to matrix whose first row elements are 2 plus 1 and 3 plus 3. Second row elements are 1 plus 4 and 5 plus 2, which is again a square matrix of order 2. As we know that for matrix addition, the matrices to be added must be of same order, and thus the addition matrix so obtained is also of the same order. Here matrix A and matrix B are of the same order, that is of order 2 by 2. Thus addition matrix A plus B so obtained is also of the same order 2 by 2. Now on solving, it is further equal to matrix with first row elements as 3 and 6, second row elements as 5 and 7, which is a square matrix of order 2. Therefore, for the given matrices, A and B, matrix A plus matrix B is equal to the square matrix whose first row elements are 3 and 6, second row elements are 5 and 7, and it is of order 2 by 2. जो कि ਅਸੀਂ पता करना ਸੀ। Now let's see another example. Given matrix A with first row elements as -1, 2, second row elements as 0, 4, and matrix B with first row elements as 4, 1, second row elements as 2, 3. Both the matrices are square matrices and are of order 2. Now verify that A minus B is equal to A plus minus B. Now its solution. Here matrix A is square matrix having first row elements as -1 and 2, second row elements as 0 and 4, which is of order 2. And matrix B, also a square matrix having first row elements as 4 and 1, second row elements as 2 and 3, and it is of order 2. Therefore, A minus B is equal to matrix A minus matrix B that will be equal to matrix having first row elements as -1, -4 and 2, -1, second row elements as 0, -2 and 4, -3, which is again a square matrix of order 2, because we know that difference of two matrices is a matrix obtained by taking difference between corresponding elements of the given two matrices. ਭਾਵ ਜਿਵੇਂ ਕਿ ਅਸੀਂ ਜਾਣਦੇ ਹਾਂ ਦੋ ਮੈਟ੍ਰਿਸਿਸ ਦਾ ਡਿਫਰੈਂਸ ਲੈਣ ਲਈ ਅਸੀਂ ਇਹਨਾਂ ਦੇ ਕੋਰਸਪੋਂਡਿੰਗ ਐਲੀਮੈਂਟਸ ਦਾ ਡਿਫਰੈਂਸ ਲਵਾਂਗੇ ਤਾਂ ਜੋ ਮੈਟ੍ਰਿਕਸ ਆਬਟੇਨ ਹੋਏਗੀ ਉਸ ਨੂੰ ਅਸੀਂ ਦਿੱਤੀ ਗਈ ਮੈਟ੍ਰਿਸਿਸ ਦਾ ਡਿਫਰੈਂਸ ਆਖਾਂਗੇ so it is equal to matrix having first two elements as -5 and 1 second two elements as -2 and 1 which is again a square matrix of order 2 here A minus B is a square matrix with first two elements as -5 and 1 second two elements as -2 and 1 and it is of order 2 by 2 now for matrix B its additive inverse that is minus P will be obtained by multiplying it with scalar -1 that is it is equal to matrix with first two elements as -1 into 4 and -1 into 1 second two elements as -1 into 2 and -1 into 3 which is a square matrix of order 2 so it is equal to square matrix having first two elements as -4 and -1 second two elements as -2 and -3 so now A plus minus B is equal to matrix A plus matrix minus B that is by matrix addition it will be equal to matrix having first two elements as -1 plus -4 2 plus -1 second two elements as 0 plus -2 and 4 plus -3 which is a square matrix of order 2 it is further equal to matrix having first two elements as -1 -4 2 -1 second two elements as 0 -2 4 -3 which is a square matrix of order 2 and further it is equal to square matrix having first two elements as -5 and 1 second two elements as -2 and 1 and it is of order 2 and also A minus B is equal to square matrix having first two elements as -5 and 1 second two elements as -2 and 1 so this implies A minus B is equal to A plus minus B so for the given matrices A and B A minus B is equal to A plus minus B hence verified
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਮੈਟ੍ਰਿਸਿਸ ਐਡੀਸ਼ਨ ਅਤੇ ਪ੍ਰੋਪਰਟੀਜ਼ ਆਫ ਮੈਟ੍ਰਿਸਿਸ ਐਡੀਸ਼ਨ ਨਾਲ ਰਿਲੇਟਡ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਕੁਝ ਹੋਰ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see another example. Simplify cos theta into matrix with first two elements as cos theta sin theta, second two elements as minus sin theta and cos theta, which is a square matrix of order 2, plus sin theta into square matrix of order 2 with first two elements as sin theta and minus cos theta, second two elements as cos theta and sin theta. Now its solution. Given that cos theta into square matrix of order 2 with first two elements as cos theta and sin theta, second two elements as minus sin theta and cos theta, plus sin theta into square matrix of elements as sin theta and minus cos